Welcome to Oracle APM tutorial series. Application Performance Monitoring is a service in Oracle Cloud Infrastructure that provides a set of solutions including distributed tracing, real user monitoring, and synthetic monitoring. This recording covers real user and EBS monitoring, which is a part 4 of the tutorial. My name is Yutaka Takatsu. I am one of the product managers in Observability and Management product management team in Oracle Cloud Infrastructure. The tutorial consists of 5 different video recordings which you can find in this Oracle channel. Each recording is about 20 to 30 minutes long. Please find the video links to other chapters from the description in this video. This is a recording of part 4, Real User and EBS Monitoring. This is chapter 9, Real User Monitoring. The real user monitoring refers to APM capabilities which are related to the client-side data. In this chapter, I will talk about the APM browser agent, which is the core of the real user monitoring, and demonstrate a real-world use case analyzing the customer journey. In previous chapters, I have mentioned that APM browser agent is one of the data sources collecting spans from the front-end side of the applications. The browser agent is the core functionality in the real user monitoring. It captures the user's interactions from web pages and generates browser spans and sends them over to APM. The deployment of the browser agent can be done by manually inserting a JavaScript code to the HTML source in your web application pages, such as index.html. As an option for Java applications, you can use Java Agent, which will automatically inject the JavaScript statement, which deploys the agent to the source pages. APM Browser Agent supports single-page applications, or SPA, such as Angular or React-based web pages. In those applications, there is only a single HTML that is downloaded, and the transaction happens by updating the page, typically using AJAX. When a page is downloaded, the browser agent creates a span for the full page update. In addition, it also creates spans for each AJAX call as a partial page update. The browser spans include out-of-the-box metrics and dimensions. For example, the page load time, or time to first byte, or time to render the page. Also includes aptX scores. It also collects information related to the user's environment, such as IP address, location of the user, type of the browser, and so on. So it carries a lot of information by default. However, every application has unique attributes which you may want to use in the analysis. Those are not captured by default. Using APM Browser Agent, you can customize the behavior and collect additional attributes from your web application. The example in the screen will create custom attributes, and one of them is shopping cart. This captures a dynamic value returns from a function. And every time the browser agent creates a span, this data is looked up and is added to the span attributes. So that is how the browser agent works. It collects data that is user-oriented. Once the spans are uploaded to APM, you can visualize in the real user monitoring dashboard or use default or custom dimensions to slice and dice the data in Trace Explorer to analyze the user trend. So we just talked about the user-defined attributes, which is one of the capabilities in Browser Agent. Let's see how this feature can be useful in real-world use case. Say you manage a shopping cart website, which is called Wine Cellar. You want to monitor the customer's in-app behavior and analyze whether the website is successful or not. To do so, you will first need to deploy the APM Browser Agent. Here's the source page of the application. You will manually insert the JavaScript code along with your data upload endpoint and a public data key so that the spans will generated and uploaded to your APM domain. Because this is a shopping cart website, the web page already has customers' purchase information, such as the dollar amount of the purchased products. You want to pick up that information too and include it into the span. So here you defined 4 custom attributes. The last one is journey phase. This attribute takes a value from a function call and stores the information of which phase in the user's purchase journey the customer currently is. The values are either search, login, add to cart, checkout, and order complete. Other three attributes such as cart value, checkout, and complete value store the dollar amount from each phase. Now let's verify what values are captured with the browser's inspection tool. Now with the inspection tool open, click the Checkout button in the web page. In the name section, there are two requests, one for the checkout and another for the span. This is a span generated by the APM browser agent and sent to your APM domain. In the payload section, there is a span information. Expand the tree view. Now you can see there are three spans generated with this request. Expand the first span node. Let's review the span information. You can see the span ID, also a parent span ID. So this is a client span, and the name is Agent Front Store Checkout. This is because the span was generated by the AJAX call. Now expand the attribute node. Scroll down. Here you can see the default RUM metrics such as AJAX download time or AJAX first byte time, and the values that are captured by the browser agent. And along with the default values, you can also see the custom values. Cart value is 297.87 and journey phase is add to cart. These key value pairs are sent to APM so that later you can use them for analysis. Now let's see this information in the Trace Explorer. Here is a Trace Explorer. The traces from the web transactions are already loaded in the screen. Let's click the trace at the top of the list to see the trace details. Because the web event was an AJAX call, which does not fully load a new page, the trace type is marked as partial update. Now click the second span which says checkout from the Gantt chart to see the span details. You can see the operation name is AJAX checkout and kind is client. These are the same information you saw in the inspection tool. Scroll down. And here is one of the custom attributes, which is the cart value. The dollar amount is also captured and included in the span. Further scrolling down, this is another custom attribute, which is journey phase. So you could confirm that the custom attributes were sent to the APM domain and you were able to see them in the span details. Close the window. Go back to Trace Explorer. Now let me open a query I previously opened from the Query History view. This is a custom query that filters the traces for those only having values in the journey phase attribute and group the result by the same attribute. The query result is showing the summary of the user journey in the application in terms of the purchase process. The number of sessions in each phase is decreasing, going from the top to the bottom. Starting from 82 at the search, 78 added something to the cart, 57 checked out the merchandise, and 43 completed the order. And remember, you also collected the dollar amount from each phase, and the total value are also calculated and displayed in the view. So looking at the values, you can tell the customers left the website and you have lost the potential revenue as they go through the process. And in fact, the Apdex score is also queried in the view. Apdex score value that is below 1 indicates the user is not satisfied. So for some reason, users were not happy at the checkout process, and that could be the reason many left website at this phase. From here, you can narrow down to checkout phase and investigate the reason why the users were not happy with this service. Moving on to the Chapter 10, Monitor eBusiness Suite application. In addition to the microservices or traditional homegrown Java applications, you can use APM to monitor Oracle's packaged applications such as eBusiness Suite, PeopleSoft, or JD Edwards, for example. Among these Oracle applications, monitoring eBusiness Suite, or EBS in short, has unique monitoring requirements. This is because EBS uses Oracle Forms, and there aren't many tools which can capture EBS users' Forms activities. Oracle APM is one of the few monitoring tools which can capture both HTML and Forms traces from EBS. In this chapter, we will discuss how APM can capture traces from different EBS components, including Oracle Forms. For over 20 years, EBS has been providing powerful business capabilities to enterprises. Now in the year 2022, while EBS continues to help users manage global businesses, users have more deployment options. What that means is that you may have EBS in on-premise data centers or on the cloud or both. They may be in the Oracle Cloud or in other public clouds such as AWS or Azure. They may be deployed on Docker or Kubernetes containers. So what can APM do for you? APM can help you to monitor EBS application, whether that is in the public cloud or private cloud in your on-premise data centers. It tracks every step of every transactions of users' EBS navigations and captures traces from HTML and Forms activities. You can run synthetic monitors on JSP pages, also collect out-of-the-box metrics from WebLogic servers, allowing you to envision the complete set of users' EBS transactions. The captured data is stored in the internal database for real-time and historical data analysis. You can query and filter the data with predefined dimensions and run deep dive analysis to identify the root cause of issues. You can use predefined dashboards or create a custom dashboard that meets your EBS use case and requirements as displayed in the screen. All these result in reduced downtime, enhanced visibility into the performance with better user experience and satisfaction. So that was a brief overview of the APM's capabilities monitoring EBS. Now let's see more into what exactly APM can do for EBS. And in fact, monitoring an EBS application is not a simple task. First of all, the web user interface includes AJAX calls that personally update the page content without reloading the full page. For example, expanding the navigator menu in the EBS homepage, which loads the menu items on the screen. There's no full page loaded because the page is only partially updated by the AJAX call. Also, EBS version 12 runs on WebLogic servers in the backend, but they may be deployed in a Docker or Kubernetes container. And the page contents include both HTML and Oracle Forms, which communicate with different backend servers using different protocols. The good news is that Oracle APM does have solutions. It supports partial page updates, supports application servers deployed in containers. Also, it captures data from Oracle Forms in addition to HTML. In this chapter, I'd like to show you how that can be done and what would you see upon enabling the tracing on EBS application. To monitor EBS applications with APM, there are three types of traces and spans you will collect from the application, and you'll need to use different data collection options. First, there are server traces and spans. For this type, use the APM Java agent as a data collector. You will need to provision the agent in the application's web server tier, then use WebLogic Admin Console UI to insert the required JVM arguments, which point to the agent location at the server start option. Second, there are browser traces and spans, which capture user actions performed on the browser. Here you will need an APM browser agent. The deployment can be done by enabling the auto injection in the Java agent, and the browser agent will be automatically deployed to the application's front end. And third, there are forms traces and spans, which you will need to set up a real user experience insight, or RUI in short. Whatever the tracer you use, every event you have in application will become a span. A group of spans is called a trace, which represents a transaction in the application. Captured traces and spans will be uploaded to APM and stored in a database. You can visualize the data in a pre-configured or custom dashboards, or use the built-in query language to extract the desired set of data to analyze and troubleshoot the application's workflow. Next, let's look at the setup architecture. This diagram shows a simplified setup of EBS application that is running in the Oracle Cloud. In the core of the application tier, there are WebLogic servers that host the EBS application. The application connects to the Oracle database with JDBC, and users of the application use JSP Web User Interface to log on to the EBS Web Console and connect to the server in Oracle Cloud through a gateway. So this is the EBS application setup you want to monitor using APM. First, you will create an APM domain and obtain data upload endpoint and data keys. Then download the APM agent installer from the APM domain. Then provision it in a shared directory in the application tier. Next, use WebLogic console to deploy the agent to the managed servers. Then restart the servers. Once the servers are back, server-side traces and spans are sent to the APM domain where the data upload endpoint was obtained. Incoming data is secured by the data key, so only the authenticated data comes into APM. And in the Java agent configuration file, you must enable the browser injection settings. This will automatically configure the APM browser agent in the application's front end. This will take effect within a minute or two. The browser-side traces and spans will be sent to the APM domain. Lastly, you will need to set up RUI to capture forms traces. You can provision the RUI app from Oracle Cloud Marketplace or manually install the RUI program in your compute instance. Then configure L2TP tunneling between the RUI server and the web tier. This will capture users' forms activity performed in their client machines and upload the traces and spans to the APM domain. And once the data collectors are deployed and configured, traces and spans start coming into the APM domain. You can see them using the APM Trace Explorer. This slide highlights the best practice tips for how to use tracing data to analyze and troubleshoot your EBS application. First of all, because the EBS traces are captured by different data collectors, they can be categorized as different services. You can see the overall statistics of each service or drill down to a specific service and see the details of it. You can also view all the traces in a single browser session. Session is a continuous user transactions performed in the browser. This typically starts at the user login and ends at the logout, or launching the browser to closing the browser. By grouping the traces by a session, you can see the end-to-end events in a chronological order. It helps you to analyze users' workflow in your application. EBS by default runs a lot of short-duration SQLs which can flood your Trace Explorer UI because each becomes a JDBC span. You can eliminate the excessive count of spans by configuring the average traces options in Java Agent. JDBC spans include a set of database dimensions that are useful to diagnose databases. If the cause of the slowness of your EBS seems to be a slow-running SQL, you can bring the data to the database management service to further diagnose your database. Lastly, EBS forms-based spans include EBS-focused dimensions such as a module name or responsibility name. Use EBS native parameters for your workflow and user analysis. Next, let's see them in the APM user interface. The screenshot shows three different services, Forms, Web, and OA Core, that categorize the type of traces collected from the EBS application. Each service includes traces, which were uploaded from the different tracers. Forms traces were collected by RUI, Web traces were collected by the browser agent, and OA Core, which is the name of the managed WebLogic server, the data was collected using APM Java agent. Here you can see the overall status of the services, number of traces included, and average duration. It also allows you to drill down to the list of the traces and see details to perform deep dive analysis on each service. Another way to look at the traces is by a session. APM provides a session ID to the group of traces that are considered executed within the same browser session. In the Trace Explorer, you can use the built-in query language to show a list of traces that were running within the same session. That is the query result which you see on the screen. And by sorting the start time in ascending order, you can see the events in the workflow in the order as they happen. That is starting from connecting to the server, following by the full page load of the login page, then partial page update by an AJAX call. Then a user log into the application, resulting in a full page load of the EBS homepage. Then a user expands the navigation menu, which results in another AJAX call to partially update the page. Then user finally clicks the menu icon that launches the Forms application. Now let's take a quick look at the trace at the user login. This trace has spans coming from two different services, Web and OA Core, which are showing bars with different colors. The browser agent captures the user's login request, and the request was processed on the server side, which was caught by the Java agent. So the spans are correlated in a single trace. And please note that there is a scissors icon at the first server-side span. This means that the spans in a trace are filtered by the average settings in the Java agent. APM by default captures all the traces and spans and stores in the database. While this provides powerful analysis capabilities to users, in some cases it may include many insignificant spans that could be ignored. Average settings allows you to trim down the volume of spans in a trace by providing a specific condition. In this example, average is enabled in JDBC probes, showing only the first three of them, otherwise hiding them unless the span duration is more than 10 milliseconds. Here shows the span details of the first server span. There is a set of average-related dimensions displayed at the top of the list. You can see the average settings is enabled, and 90 JDBC spans were abridged because their durations were less than 10 milliseconds. To see what JDBC calls are averaged, you can view them in the log entries, which shows a list of SQLs that are taken off from the Trace Explorer Gantt chart screen. Okay, so I am back at the Trace Explorer screen. There are few JDBC spans that are taking longer than 10 milliseconds. Let's open one of them. Because this is a JDBC span, database-related dimensions are shown in the span details view. You can see the database connection string, SQL ID, and actual SQL executed. The duration of the span was 47 milliseconds and may not be too slow, but in case you see a really slow SQL, you can bring this information to further diagnose the database. Also to note, the EBS traces and spans contain application-specific dimensions. In the field section in the main page of Trace Explorer, you can filter the list of dimensions by a keyword EBS. This shows a list of EBS dimensions such as EBS form ID, form name, EBS module, or EBS responsibility. So for example, selecting the EBS module name dimension opens a pop-up screen that shows the values and accounts of the module names appearing in the queried traces. In this example, the human resource module was hit twice in a single session. And there is an instant query button in this dialog. When you click this, it inserts the selected condition to the query. In this case, the EBS module name equals human resource. You can hit the Run button to drill down to the set of traces that meets the condition. So the screen now shows two form-based traces that have human resources as the EBS module dimension. Taking a look at the span details view, one of the dimension entries show Rui as the data collector, so you know this is a form-based span. The span also includes the EBS dimensions such as EBS action, EBS class, component, form ID, form name, framework name, also module name and responsibility. All these help you to understand the user operations and experience in your EBS application when correlating the EBS dimension values with the performance data. This is the end of the recording of Part 4, Real User and EBS Monitoring of Application Performance Monitoring Service in Oracle Cloud Infrastructure. Please find the links to other chapters of the APM tutorial series from the description in this video. Thank you for watching.